A device to rip apart the very atoms of water. This is the science of electrolysis. Electrolysis is where you take a substance and split it into its ions using a strong DC. For instance, if you have water, you apply a strong current for it and you split it into hydrogen ions and hydroxide ions, which then combine to form hydrogen gas and oxygen gas. Electrolysis is also used in metals, whether you want to get a purer substance out of like an old piece of copper, or whether you're going to take something like an aluminium ore and convert that into pure aluminium. As a result, there is a lot of industry interest in electrolysis, all the way from hydrogen production to the production of metals and other compounds. Let's have a look at electrolysis in action. Starting with a container of salt solution, we introduce the battery. Usually, you'd use two conducting rods, but this way we can find some more interesting chemistry. Bubbles rapidly form on the negative terminal, but not so much on the positive terminal. However, if I speed up the footage, we can see another substance begin to build up upon the positive terminal. If I had used two rods, or electrodes to give them their proper name, you'd have expected bubbles to form at both the negative and the positive end. However, the casing of the battery reacts with what is forming at the positive end. Let's take a look at what happens. In our experiment, the two ends of the batteries were the electrodes, and we placed them in a saltwater solution so that the ions of the salt could then form the electric current between the two electrodes. At the positive electrode, the electrons have been pulled away by the potential difference. This means that any water molecule that passes by has its electrons ripped off of it by the strong positive charge. This causes the water molecule to split into an oxygen atom and two hydrogen ions. In our experiment, the oxygen atom then bonded with the metal in the electrode. The hydrogen ions then form part of the current. The negative electrode has an abundance of electrons and wants to give them away. It does this with the hydrogen ions in order to form hydrogen gas, and it also injects them into water molecules to form a similar reaction, which ends up with hydrogen gas and hydroxide ions. And thus you end up with hydrogen gas at the negative electrode and a metal oxide at the positive electrode. However, if you do use an inert electrode, you end up with bubbles of oxygen instead of the metal oxide.